If you are drowning in security alerts while trying to ship software faster, you are not alone. Traditional application security tools were built for a slower era. They generate thousands of findings, most of which never translate into real risk. Ox Security takes a different approach. In this review, we will explain what Ox does, how it prioritizes the 5% of issues that actually matter, how it supports modern software supply chains, how it treats AI-generated code, and whether it is the right fit for your team. Ox Security was founded in 2021 by Neatsun Ziv and Lior Arzi, veterans of Check Point. Their timing was not an accident. The SolarWinds attack in 2020 made it clear that the software supply chain is a prime target. When attackers compromise a trusted build or update, they can reach thousands of downstream organizations. Security leaders realized their tools were siloed. SAST flagged code smells, SCA flagged vulnerable packages, container scanners flagged image issues, and cloud tools flagged misconfigurations. But no single pane tied these signals together to show what was truly exploitable in the context of a specific application and environment. Ox set out to close that gap. At its core, Ox is an application security posture management platform. It connects to your source control, CI or CD pipelines, artifact registries, and runtime environments. It ingests findings from your existing scanners and performs correlation, deduplication, and enrichment. It then constructs a code-to-cloud map that links a vulnerability or misconfiguration to a service, owner, and deployment location. The goal is simple. Stop chasing everything. Fix the few issues that create real attack paths. How does Ox decide what matters? The platform blends several categories of signals. First are vulnerability indicators. These include well-known metadata such as CVSS scores, exploit maturity, and listings in the CISA known exploited vulnerabilities catalog. Many organizations also weight EPSS, the exploit prediction scoring system, to identify issues that are more likely to be exploited in the near term. Second are reachability and exposure signals. Ox looks at whether the vulnerable function is actually invoked in your code, whether the service is internet-facing, whether the component sits in a privileged runtime, and whether identity or network policies could allow lateral movement. Third is business context. The platform ties vulnerabilities to specific services, repositories, and owners, and allows teams to factor in data sensitivity and asset criticality. When you combine exploitability, reachability, and business impact, you get a ranked list that aligns with risk, not noise. Ox's supply chain coverage addresses the entire development lifecycle. It inventories open-source dependencies and produces SBOMs, so you know exactly which components exist in each service. It inspects CI or CD configurations to detect risky practices such as unsigned artifacts, missing integrity checks, or permissive pipeline permissions. It evaluates container images and infrastructure as code for misconfigurations that could magnify blast radius. By linking source, build, registry, and deployment, Ox helps you trace a CVE from the package in a repository to the running pod, function, or virtual machine. A frequent question is whether Ox uses AI. The answer is that Ox applies automated correlation, analytics, and context enrichment to reduce noise and surface the most relevant paths to exploitation. Some customers describe this as AI-assisted, because the system reasons over graphs and patterns that would be impractical to do by hand. The important takeaway is the outcome. Teams spend less time triaging and more time fixing issues that close real attack paths. Another question is how Ox handles AI-generated code. From a security perspective, the origin of the code does not change the types of issues that matter. Ox scans repositories, pull requests, and pipelines, and detects problems in generated code the same way it does for human-authored code. This includes secrets exposure, insecure defaults, license compliance violations, and the introduction of vulnerable packages. If your organization tags AI-assisted commits or requires additional reviewers for generated code, Ox can use repository metadata to enforce guardrails in pull request checks and CI policies, ensuring higher scrutiny where it is warranted. Ox is not intended to replace every scanner. Many teams bring their preferred SAST, SCA, secrets, IAC, and container tools. Ox aggregates those findings, removes duplicates, normalizes severities, and enriches them with environmental context. The platform also offers built-in checks to fill coverage gaps. This approach lets you standardize workflows and measure risk at the application or service level, rather than per tool. You can open a single ticket in Jira that contains all the evidence an engineer needs to reproduce and fix the issue. You can also track service-level objectives for remediation and automate escalation when high-risk issues linger. Integration is a key part of adoption. Aux connects to major source control platforms such as GitHub, GitLab, and Bitbucket. It works with common CI systems and artifact registries. It can notify teams and collaboration tools and synchronize issues with ticketing systems. This reduces friction and ensures that context-rich alerts meet developers where they already work. How does Aux compare to other vendors? If you rely primarily on a single vendor for scanning, such as SNCC, Checkmarx, or Veracode, you will get strong detection coverage within that domain. Aux is stronger when you need to unify multiple tools and add code-to-cloud context that those point solutions do not provide. Against other ASPM-style platforms, Aux differentiates with its explicit focus on exploitability and reachability, the 5% that matters. Your selection should hinge on two questions. Does the platform map vulnerabilities to running services with owner attribution? And does it help you decide what to fix first with evidence you trust? Who benefits most from Aux? High-velocity engineering teams that experience alert fatigue, organizations with many microservices or multiple business units, companies subject to regulatory scrutiny that need SBOM coverage and policy enforcement across pipelines. If you must answer where a CVE is running, who owns it, and whether it is exploitable in your environment, Aux provides that visibility. What about pricing and deployment? Pricing varies by factors such as number of repositories, services, or users. Deployment typically involves connecting integrations and ingesting findings. Most teams start by integrating source control and CI, onboarding a subset of services, and validating the prioritization model before scaling. Before deciding, run a proof of value. Bring in real data from your code, pipelines, and runtime. Measure noise reduction, mean time to remediation, and the accuracy of risk ranking. Validate that tickets include actionable context and that your developers accept the workflow. The right tool will show you a short list of issues, each clearly tied to a service, an owner, and an attack path you can verify. In summary, Aux Security addresses the central problem in modern AppSec. Teams do not need more alerts. They need the right alerts grounded in exploitability and business context. By mapping code to cloud and ranking issues by real risk, Aux helps organizations fix less and secure more. If your objective is to focus on the vulnerabilities that can actually hurt you and to prove that fixes reduce attack paths, Aux is worth a serious look.